Welcome to lecture 8.4. We're going to discuss volume. Now, volume is the space enclosed in a solid. We're going to start off kind of slow and move into more irregular shapes. So the volume of a rectangular solid would be the length times the width times the height. So L times W times H. Pretty straightforward. Let's find the volume of a rectangular solid with the length of 15 inches, the width of 3 inches, and the height of 5 inches. So again, the volume of a rectangular solid is length times width times height. So 15 inches times 3 inches times 5 inches. That would give me 225 inches cubed. Why inches cubed? Because I have inch times inch times inch. Well, that's inch times inch times inch is inch cubed. Our next geometric shape we're going to find the volume of is a cylinder. Now this particularly is a right cylinder. What I mean by right cylinder is the edge of the cylinder and the bottom of the cylinder make a right angle. So it's not tilted, it's straight up, and it's perpendicular, it has a right angle. So the volume of the cylinder is going to be pi radius squared times height. So pi r squared height times height. But let's take a moment back and think about that. Right? Remember, the bottom of a cylinder is a circle. And how do I figure out the area of a circle? Well, that's pi r squared. Now, the height of a solid cylinder, if you can imagine, is just laying circle on top of 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 circle until it is h in height. Hence, find the area of the circle, multiply it by the height, and that's how you get the volume of a cylinder. For example, let's consider a drinking straw with the radius of 0.25 inches and the length of 6 inches. How much fluid can it hold? Well, the volume of fluid is going to be what fills the straw. So we're going to use our equation of pi r squared times h, where the length in this situation is actually the height of our cylinder. So volume equals pi r squared h. Plug in our values. Pi times 0.125 inches squared times 6 inches. That will give me 0.09375 pi inches cubed. And if you know me by now, I do like to do the pi at the very tail end. So I'm going to approximate it as 3.14, giving me approximately 0.294 cubic inches of volume of liquid. Let's consider a volume of a cone. Now, a volume of a cone isn't as simple as the volume of a cylinder because our sides are collapsed. So here's your formula, not an easy way to remember it, but just try to memorize it. The volume of a cone is 1/3 pi times the radius squared times height. Okay, so it's almost of a cube, or almost of a cylinder, but you have the 1/3 out front. Okay, so 1/3 pi r squared h. For example, let's find the volume of a cone with the height of 5 centimeters and the radius of 3 centimeters. Using our equation, volume equals 1/3 pi r squared h. We're going to have 1/3 pi, 3 centimeters squared, times 5 centimeters. 3 centimeters squared is 9 centimeters squared. 9 centimeters squared times 5 centimeters squared is 45 centimeter cubed. 45 and 1/3 will give me the 15 pi centimeter cubed. That's approximately 15 times 3.14 centimeters cubed, giving me 47.1 rounded centimeters cubed would be the volume of this cone. One more geometric shape. Let's go for the volume of a sphere. So think of this not only as a ball, but maybe it's a solid metal ball. That would be a sphere. The whole entire entire volume of it. So it's 4/3 pi radius cubed. It's cubed, not squared, cubed. So it's 4/3 pi r cubed. So let's kind of combine what we've done so far. I didn't show you an example of a sphere, but if I tell you the radius, you're just going to plug it in to the equation and figure it out. Think about a capped silo that's composed of a right circular cylinder with a hemisphere on top. Let's find the total volume if the radius is 5 inches and the height is 10 inches. So the total volume is going to be the volume of the cylinder plus the volume of the hemisphere. Remember, a hemisphere is half a sphere. So the volume of the cylinder is going to be pi r squared h. The volume of the hemisphere is going to be 1/2 times the volume of the sphere, which is 4/3 pi r cubed. For height, I'm going to put in 10 inches. For radius, I'm going to put in 5 inches. And I'll let you see all my work. And it goes all the way down. I'll lift it up in just a second. So for the volume of the cube, it comes down to 250 pi inches cubed. And I went ahead and left it at pi because I'm still doing some pi work down here. For the volume of the hemisphere, it ends up being 250 over 3 pi inches cubed. Add the two together. I just found common denominator, giving me 1,000 over 3 pi inches cubed. Couple more steps. 1,000 divided by 3 is 333.33333 pi inches cubed. I'm going to approximate it at 3.14, giving me approximately 1,046.7 inches cubed. When you see a complex figure that has multiple shapes together, just break it down little bit by little bit. Volume of the cylinder, figure that out. Volume of the hemisphere, figure that out. If it's a volume of the hemisphere on top of a cone, figure those out separately and add them together. So let's apply this to something that may make sense. So it's estimated that Americans drink 137 million bottles of water each day. If the average bottle has the height of 6 inches and the radius of 1.25 inches, what is the volume of the water? Let's think about applying what we've learned so far. So it's estimated that Americans drink about 137 million bottles of water every day. We're staying hydrated, apparently. If the average bottle has the height of 6 inches and the radius of 1.25 inches, what is the volume of water in cubic inches? Now, I'm going to consider this problem just a cylinder problem. Yes, I know most bottles have ridges and stuff, but let's simplify it and just say that it's a cylinder. So, a cylinder bottle would have the volume of pi r squared h. My radius is 1.25 inches, and my height is 6 inches, so I'm going to plug that into my formula. I'm going to ultimately get 29.4 cubic inches in one bottle of water. But now I'm going to multiply that by 37 million. That gives me 4,027,800,000 cubic inches of water. So I was kind of curious that value really doesn't mean too much for me. I'm not too sure what a cubic inch of water is. You know, maybe it's a volume of water, 1 inch by 1 inch by 1 inch. I get that. But 4 billion of those, it's about 17, and I'm just going to say 17.5 million gallons of water, which is about 1 square mile. 1 square mile of water. It's ridiculous. It's a lot of water when you think about it, but we do need it. We need to drink. Now it's your turn to show me what you've learned. For our next class session, here's your problem. On our trip into town, we stop and we get an ice cream cone. If the ice cream cone is composed of a cone and a hemisphere measuring 1.1 inch in radius and 3.4 inches in height, what is the volume of ice cream in cubic inches? So until next time, be seeing you.